on to systems without n linearly independent eigenvectors. So recall a homogeneous system of the form y prime is equal to capital A times y, where A is an n by n constant matrix. A homogeneous system of this form has solutions y equals xi times e to the lambda t, where lambda is an eigenvalue and xi corresponding eigenvector. And we saw if all the eigenvalues were real, and there were n linearly independent eigenvectors, then we could form a fundamental set of solutions using these xi e to the lambda t's. So if we had n linearly independent eigenvectors, then we could build a fundamental set of solutions with the xi e to the lambda t's. So the question becomes, what happens if we do not have n linearly independent eigenvectors? So what happens if all eigenvalues are real but we do not have n linearly independent eigenvectors? So this can only happen if we have a repeated eigenvalue. So this can only happen in the case of repeated eigenvalues. Of multiplicity k. where the corresponding eigenspace has dimension less than k. There are lots of ways this can happen. We're going to focus on a few specific cases. And so this can happen in many ways, particularly with larger matrices. So we'll focus sort of on three specific cases. So case one, we'll be looking at an eigenvalue of multiplicity 2. With eigenspace dimension 1. Case 2, we will look at the case where we have eigenvalue of multiplicity 3. With eigenspace of dimension 1. And case 3, we will look at eigenvalues of multiplicity 3. With eigenspace of dimension 2. So just note these three cases along with the 10-4 material covers all 2x2 and 3x3 systems with only real eigenvalues. We will not be covering those some of the cases for n greater than 3. You could keep going, sort of expanding on the techniques we'll be learning in this section if you wanted, but we will be focusing on the cases you hit with 2x2 and 3x3 systems. Then in section 10.6, we will see what happens with the complex eigenvalues. So next video, we will look at our case 1, where we have eigenvalue of multiplicity 2 and eigenspace with dimension 1.